Okay, last. We got a last set of congruency methods here. We got hypotenuse, leg. So our first statement given, we're going to say LKN and angle NML are right triangles. Given. So in this picture, it is obvious where our right angles go. LKN, this is our right angle, and then NML, this is our right angle. Sometimes in a proof they'd have to tell you specifically which angle is the right angle. Okay. Next, given LK is congruent to NM. LK and M. So this is given. And then we want to look at our triangle and see if we have any other information that's going to help us. This side is the same. So we're going to say LN is congruent to LN. And that is reflexive. And we know what has to come last. So this is where I would normally say angle, angle, and side, side, and side, side. But that method, two sides and an angle, is not a congruency method. So that is not what I'm going to use for this triangle. This is special because it's a right triangle. When I have a right triangle, I want to look for my last congruency method, which is hypotenuse, leg. Remember that hypotenuse is the side that's across from the right angle. So we know these are the same because they're the shared side. And then leg just means one of the other sides. Okay, so this is a leg and this is a leg. To use HL, you just have to know the hypotenuse and the leg if it's a right triangle. Okay, this only works for right triangles. Right triangles are the only ones that have a hypotenuse. Okay, so hypotenuse, leg, congruency. Okay. Number 10, it says triangle DEF and triangle GHF are right triangles. That is given. So again, in this picture, it's obvious these are the right angles. So I'm going to mark my diagram like that. It says F is the midpoint of DG. That's given. So F is in the middle, so these are the same. So DF is congruent to GF by definition of midpoint. And then last it has DE is congruent to GH. So DE is congruent to GH, and that was given. Okay, we know what goes last because it's our proof statement. So now we have to figure out why. Again, this is a right triangle. So because it's a right triangle, we want to look for our hypotenuse. We're given the hypotenuse in both. And then the other side is the leg. So this is our HL theorem.